Hello guys, so welcome back to our online organic chemistry lecture series, and this time we'll look at how to give names for benzene molecules and its derivatives. So the first thing we have to look at is how to give names for monosubstituted benzenes. So for these types of compounds, they are named by attaching the name of the substituent as a prefix to benzene. So for example, if we have a fluorine that's attached to the benzene ring, this is named as fluorobenzene. So we'll use the same way of naming the other three compounds here. So for example, if we have chlorine that is bonded to the benzene ring, that is named as chlorobenzene. If we have bromine that is bonded to the benzene ring, that is what we call as bromobenzene. And if we have a nitro group that is attached to your benzene ring, that one is known as nitrobenzene. There are many simple monosubstituted derivatives of benzene that have common names. For example, if we can have here your methylbenzene, this is known as toluene. If we have a hydroxy group bonded to your benzene, then this is known as hydroxybenzene, or in non-IUPAC way of naming, this is also called phenol. If we have an amino group bonded to your benzene ring, then this is known as aniline or aminobenzene. Now, if you have a sulfonic acid bonded or attached to your benzene ring, then this is called benzene sulfonic acid. Now, for this type of molecule, we have a methoxy group bonded to your benzene ring. So for the systematic name for this one is methoxybenzene, but the common name for this is anisole. If we look on this molecule, we have a carboxylic acid attached to your benzene ring. The systematic name for this molecule is benzene carboxylic acid. Now, the common name for this molecule is benzoic acid. Lastly, if we look at this molecule, this is a ketone functional group, and this is named under systematic name as methyl phenyl ketone. Now, in common name, this is known as acetophenone. We can also name some disubstituted benzenes, and for this type, we have to know the relative positions of the substituents with each other. We have here the prefixes ortho, meta, and para, and they're abbreviated as O, M, and P to denote the relative positions of the substituents with respect to the benzene ring. Now, the prefix ortho signifies a 1,2 disubstituted benzene ring. A meta signifies 1,3 disubstituted benzene ring. And a para signifies 1,4 disubstitutions. All right, let's look at some of these examples to apply this ortho, meta, and para ways of naming your disubstituted benzene rings. Let's look at this first example. So this is 1,2-dibromobenzene, but because the substituents are in 1,2 positions with respect to each other, then we just simply use ortho-dibromobenzene, or this is an ortho substituent. Remember, for an ortho substitution, we have 1, 2 positions of the substituents. Now, moving on, if we have here a 1,3 position, we can name this one as 1,3-dibromobenzene, or simply we could just name this as meta-dibromobenzene. And lastly, if we have a 1,4 position of the substituents, then we can name this one as 1,4-dibromobenzene. Or we can also name this one as para-dibromobenzene. Again, we use the ortho prefix to denote a 1,2 substitution. We use the meta prefix to denote 1,3 substitution. And we use the para prefix to denote 1,4 substitution of the benzene rings. All right, so we can also use the ortho, meta, and para prefixes to denote when we have a specific base name for the benzene. For example, if we have here a nitro and a carboxylic acid attached to your benzene ring, the base name becomes benzoic acid because carboxylic acid is higher priority than the nitro group. So the name becomes 2-nitrobenzoic acid, or simply we can call this one as orthonitrobenzoic acid. We have this example here. We have a methyl group and a hydroxy group bonded to your benzene ring. Now, between the hydroxy group and the methyl group, the hydroxy group is higher priority. Therefore, the base name of the benzene becomes phenol. So the name becomes 3-methyl-phenol. The other name for this molecule is meta-methyl-phenol. We have here a 1,4-disubstitution product, and if you notice here, you have a halide and a methyl substituent. Now, between these two substituents, the priority is the methyl group. So the new base name becomes toluene. And since we have a 1,4-disubstitution here, we can name this as 1-chloro-4-methylbenzene. It is also interesting to know that we have here some isomers of dimethylbenzenes, and they're called silenes. So, for example, if we have two methyl groups bonded to your benzene ring, this is named as 1,2-dimethylbenzene. The common name for this molecule is called orthosilene. If we have two methyl groups bonded to your benzene ring in a 1,3 position, the IUPAC name is 1,3-dimethylbenzene. The common name for this molecule is metasilene. And lastly, if we have a 1,4-dimethyl substitution of the benzene ring, the IUPAC name for this one is called 1,4-dimethylbenzene. The common name for this molecule is parasilene. Now, how do we give names for benzene rings containing more than two groups? We have to remember here that the ortho, meta, and para prefixes are not used when there are three or more substituents that are present on the benzene rings. Rather, we have to use numerical locants. All right, so we also have to know that for benzene rings with more than three or more substituents, we have to give the lowest possible numbers to the substituents. We'll try to discuss these rules in the following examples. Now, in the first example, we have a tri-substituted benzene ring, and we have 3 chlorine atoms bonded to the benzene ring. Right, so this rule tells us that we have to give this substituents the lowest possible set of locants. So the naming will become 1,2,3-trichlorobenzene. Now, if you look at this example, we have 3 bromine atoms bonded to the benzene ring, and the numbering should be done in such a way that the bromine atoms will receive the lowest possible numbers. So the numbering should start from this carbon atom going to this carbon atom. And in doing that, we'll have 1,2,4-tribromobenzene. Now, if we number this benzene ring in a counterclockwise manner, that is 1, 2, 3, and 4, then we will have a set of locants to be 1, 3, and 4, and this is higher than 1, 2, 4. All right, so the next thing we have to know is that when we actually write the final name of the molecule, then these substituents must be listed in alphabetical order. Let's look at this following example. So we have here a chlorine, fluorine, and bromine atoms bonded to your benzene ring. Now remember, we should number the benzene ring in such a way that it will give the lowest possible set of locants for the substituents. And doing that, we should number the ring starting from this carbon and going through a clockwise direction. The final name will be 4-bromo, 1-chloro, 2-fluorobenzene. Again, in the writing the final name, it is based on alphabetical ordering of the substituents and not on the number of locants. Okay, so how do we give name now for benzene rings in which one of the substituent will give the benzene a new base name? Okay, so for this type of molecules, then the carbon bearing the substituent that gives the benzene ring the new base name becomes carbon number 1. And the numbering of the benzene ring should give the substituents still the lowest number of locants. For this example, if we have a hydroxy group bonded to the benzene ring, then this entire molecule gives a new base name, and that is a phenol. If we number the ring, we also have to make sure that the chloro substituents should still get the lowest possible set of locants. So the name for this molecule will become 3,5-dichlorophenol. Okay, so let's look at another example to explain this rule. So we have here a benzene ring that has a methyl group, a bromine atom, and a carboxylic acid group. Now, the carboxylic acid group is of higher priority as compared to these two other groups. So the carbon in the benzene ring that is attached to the carboxylic acid group becomes the priority because this carboxylic acid bonded to the benzene gives this molecule here a new base name, and that is benzoic acid. Again, we number the benzene ring in such a way that the methyl group and the bromine atom will still receive the lower set of locants. So the numbering will be starting from this carbon. So we have 1, 2, 3, 4, and 5. And the final name will be 5-bromo-2-methyl benzoic acid. In writing the final name, you have to remember again that the substituents are listed in alphabetical order. All right, so if we have a C6H5 group, that is called a phenyl group. And we have rules on how we give names for molecules containing the phenyl group. Now, if the hydrocarbon is composed of one saturated chain and one benzene ring, it is usually named as a derivative of a larger structural unit. However, if the chain is unsaturated, then the compound may be named as a derivative of that chain regardless of the ring size. We will learn more of these rules in the following examples. All right, so let's consider the first example. So we have here a benzene ring and a substituent that has 4 carbons. And since the ring has more carbons as compared to the substituent, then this molecule is named as a alkyl substituted benzene. Or in other words, this is named as butyl benzene. All right, so let's try to look at this another example here. So we have here your isopropyl group that is bonded to the benzene ring. Now, if we compare the number of carbon atoms on the benzene ring versus this one, then the benzene ring has more number of carbons as compared to the isopropyl group. So again, this molecule is named as alkyl substituted benzene, or this molecule is named as isopropyl benzene. All right, let's take a look at this example here. So we have here a benzene ring, and this ring is attached to a 4-carbon alkyl group, and the alkyl group contains a double bond. And in this case, the benzene ring is treated as a substituent of this alkyl group. So this one is named as trans-1-phenyl-1-butene. So this becomes the parent. Now, let's try to consider this example. So we have here a benzene ring, and this one is attached to your alkyl group, and this one doesn't have any unsaturation, but the alkyl group has more carbon atoms than the benzene ring. So in this case, the phenyl ring becomes a substituent of a larger structural unit, which is this alkyl chain here. And the name for this one becomes 3-phenyl octane. Again, the numbering of the parent chain starts at the end nearest the first branch point or the first substituent, and that is the phenyl ring. And if you notice at carbon number 3, this is a chiral carbon. And if we look at the absolute configuration of this chiral carbon, has an R configuration. So another important group that contains the benzene ring is what we call as the benzyl group. And this is an alternative name for a phenyl methyl group. And sometimes you will see this abbreviated by the symbol BN. So how does the benzyl group looks like? So it looks similar to your phenyl group. So the only difference from a phenyl group is the presence of a CH2 group here. So this molecule is named as benzyl group. So an example of this is this molecule. So you have here a CH2 bonded to a chlorine atom. So this is named as benzyl chloride. All right, so the last topic in this video is how to give names for aldehydes and ketones. Now, just to give you a preview in the structure of aldehydes and ketones, these are organic molecules containing an acyl group. So when I say an acyl group, this is actually an R group bonded to a carbon, and this carbon is bonded to a oxygen atom. So this is an acyl group. Now, if you have here another R group bonded to the carbonyl carbon, this is known as ketones. If, for example, instead of the R group that is bonded to your carbonyl carbon, if you have here, for example, a hydrogen, then this is what we call as aldehydes. Okay, so how do we give names for aldehydes and ketones? So the rules are as follows. So if we have an aldehyde, then the parent suffix should end in AL. Now, if we have a ketone, then the parent suffix should end in ONE or ONE. Just like what we did in the previous discussions of organic nomenclature, the first thing we have to do is to find the parent. And the parent for aldehydes and ketones should still be the longest continuous carbon chain, and this should contain the carbonyl carbon. The numbering should always start at the end or at the carbonyl carbon. Okay, so we have some examples for us to apply the rules. Okay, so if you look at this one, we have here an aldehyde, because if this is the carbonyl carbon and then this carbonyl carbon is bonded to hydrogen, so this makes the molecule as an aldehyde. Now, the first thing we have to do is to find the parent, and the parent should be the longest continuous carbon chain, and the parent should also contain the carbonyl carbon. So the parent is actually this chain here, which is composed of 5 carbon atoms. So this is named as pentanal. Again, the suffix for aldehydes should end in AL or al. We should remember that we should start numbering at the end nearest the carbonyl carbon, or at the carbonyl carbon itself. So in this case, the numbering starts on this carbon. So 1, 2, 3, 4, and 5. Notice that in this molecule, we have a substituent at carbon number 4. So that is a chlorine. And at carbon number 2, we have the same types of substituents, and those are methyl groups. So when we write the final name, so we have to make sure that the substituents are written in alphabetical order, just like what we're doing in the previous discussions. The naming will be 4-chloro-2,2-dimethyl pentanal. Again, since we have the same types of substituents here, in this case, methyl groups, so we use the prefix di. And do not forget to write or indicate the locant. So in this case, we have here 2 for the dimethyl substituents and 4 for the chloro substituent. All right, let's take a look at this example. So we have this carbonyl carbon, and if you notice that the carbonyl carbon is bonded to 2 carbon atoms, that's why this is actually a ketone and not an aldehyde. Just like what we did for the first example, we have to look up or find the parent chain. And again, the parent chain should be the chain that has the most number of carbon atoms, and secondly, it should contain the carbonyl group. So if you look at this one, we have this chain here which has 7 carbon atoms, and that becomes the parent chain. And aside from that one, this chain also contains the carbonyl carbon. How do we number this chain? So numbering starts at the end nearest the carbonyl carbon. So I should number starting from this carbon, going from left to right. For ketones, we should also indicate the location of the carbonyl carbon. So in this case, at carbon number 3, you have the carbonyl carbon there. So we will write here 3-heptanone. For aldehydes, this is not a problem because we know that the carbonyl carbon for aldehydes are always terminal. They're always at carbon number 1. But for ketones, this is a different story because the carbonyl carbon is an internal carbon. It is not a terminal carbon. Notice at carbon number 4, we have an ethyl group, and at carbon number 6, we have a bromine atom. In writing the final name, it becomes 6-bromo-4-ethyl-3-heptanone. Again, do not forget to write the substituents in alphabetical order and the location of the substituents with respect to the main chain. So we can also have this C double bond OH as a prefix, and that becomes a methanoyl or a 4-mil group. Now, when this group is used as a prefix, this can be used as ethanoyl or an acetyl group. And lastly, we can also have any R group bonded to the carbonyl carbon, and that is named as alkanoyl or acyl group. All right, let's use these groups in the following example. Okay, so let's try to consider this example here. So you have a benzene ring bonded to a carboxylic acid and a 4-mil group. Between the 4-mil or methanoyl group and the carboxylic acid group is a higher priority than this one. So this group contributes to the new base name of this molecule. So the new base name becomes benzoic acid. Since this is the priority, the carbon bearing this group will be first carbon. This will be the second carbon. So the final name for this one will be 2-methanoyl benzoic acid or ortho-4-mil benzoic acid. Okay, now let's try to consider this other example here. So we have here a benzene ring and we have two substituents. So we have here a sulfonic acid group and an ethanoyl group. So between the sulfonic acid and the ethanoyl group, the sulfonic acid is the priority. So this one will contribute to the new base name of this benzene ring. So the new base name is called benzene sulfonic acid. Now, you would recognize that the sulfonic acid group are in a 1,4 position with respect to the ethanoyl group. So the name of the molecule can be written as 4-ethanoyl benzene sulfonic acid. Or we can also write this as para-acetyl benzene sulfonic acid.